Hello! Today we are going to start a very interesting topic. It is the balancing of chemical equation. Balancing of chemical equation is always a tough task for us, is it? Whenever we get an equation, we will get confused. Oh, what number we have to put it or where to put. Every time it's a confusion. So, after hearing this class, this balancing the equation is going to be one of the interesting part in our chemistry. So before we are going to our class, those who are not subscribed in the channel, please click the button, subscribe button, which is at the down, you can see there, and a bell icon is there. By clicking that bell icon, you will get the regular updates. So we can go to our class. So which is the topic? The balancing the chemical equations. Before starting that, we should know what is a chemical equation. What is a chemical equation? What is that? A chemical equation is a representation of a chemical reaction. It is a representation of a chemical reaction. It gives an idea about which all compounds are participating and what all products we are getting after the chemical reaction. So what is a chemical reaction, chemical equation? A chemical equation is a representation of the reactants and the products and also the direction of reaction. It was the 3 points. It tells about the reactants, the products and the direction of the reaction. What is a reactant? So very simple. The compounds or the elements which are participating in a chemical reaction or the starting material of a chemical reaction. The arrow represents the direction of the chemical reaction, in which direction the reaction is going, that is in forward or in the backward direction. The product gives us about the idea what all things are produced after the chemical reaction. So this is a chemical equation and these are the representations which we can see inside a chemical equations. So going with the balancing of the chemical equation, we should know some of things which is inside a chemical equation. We just consider this a general representation of a reaction. General A plus B gives C plus D. Here A and B are the substance which are reacting. So they are called as the reactants. What they are called as? They are called as the reactants. And this arrow represents the direction of the reaction. This is a forward reaction. That means A and B are reacting to produce C and D. What is produced here? C and D. So C and D are the products. Got it? This is a representation of a chemical reaction. This can be explained with an example. We know hydrogen H2 plus O2 gives H2O. Hydrogen reacted with oxygen to produce water. Here we are representing the chemical equation by the simples. H is the simple for hydrogen, we know O for oxygen and H2O is water. Now in this equation you can see many things like numbers are seen there. You can see apart from the simples we can see numbers. What are these numbers represent? What are these numbers? In a chemical equation, we can see numbers like which is written before a simple or which is written just like a subscript for a simple. What these represent? So, there are two types of numbers which we can see. That is, one we can call it as coefficient and second one is called as the subscript. These two are very important. What this represent? This is called as the coefficient and this is called as the subscript. These two are different. So we have to explain what it is. By knowing this only we can go with our balancing. So what this coefficient number means? This number, the coefficient represents the number of molecules participating in a chemical reaction. number of molecules participating in a chemical reaction. Whereas the subscript represent the number of atoms of that element. Number of atoms of that element is present in that compound or in that molecule. Number of atoms of an element participating in a chemical reaction, or it is present in a chemical compound. So what this represent? Coefficient represent the number of molecules participating in a chemical reaction, and the subscript represent the number of atoms of that element in that compound or in that reaction. I will explain this. For example, 2H2 means two molecules of hydrogen. Two molecules of hydrogen, and this represent this. Here no coefficient, so we can write it like, we can explain like one molecule of oxygen. This represent two molecules of water. Then what the subscript indicates here? The subscript tells us about the number of atoms. That is, here there are two hydrogen atoms. That means altogether there are 4 hydrogen atoms. There are 4 hydrogen atoms. Here there are 2 oxygen atoms. And here there are 2 hydrogen atoms and 1 oxygen atom. Or we can say that is, here we have altogether 4 hydrogen atoms and 2 oxygen atoms. So the coefficient represents the number of molecules, and this subscript represents the number of atoms of that element participating in that reaction. For example, we consider the molecule of water. This is water. In water, we know that there are 2 hydrogen atoms and 1 oxygen atom. This two represent there are 2 molecules of water. What does represent? 2 molecules of water. If I am writing it like this, 2H2O2. What does represent? This represents 2 molecules of hydrogen peroxide. H2O2 is hydrogen peroxide. This represents 2 hydrogen atoms and 2 oxygen atoms are there. That means the compound is changed. The compound is changed. That is, instead of 2H2O, I wrote here 1 more oxygen. The contribution, 1 more oxygen is contributing. 1 more oxygen atom is contributing to this compound. That means the compound is changed. Here it is H2O, 2 hydrogen atom and 1 oxygen atom. 2 molecules of water and 2 molecules of hydrogen peroxide and 2 molecules of water. Now you will identify why I gave this example. In balancing an equation, we are not supposed to change. We are not going to balance the equation by giving the values at the subscript. You are getting? We are not going to balance any chemical equation by giving any number at the subscript. We can balance a chemical equation only by giving a number as coefficient. We can change the coefficients. We are not supposed to going to change the subscript. If we change the subscript value, the compound is going to change. The compound, if I want to balance an equation, if I putting here 2, the compound is changed. That means H2O2, it is not water again, it is hydrogen peroxide, which is entirely different from water. So the first thing you have to keep in mind is that whenever we are balancing, we are supposed to change the coefficients and we are not going to change any value at the subscript. Got it? That's why I tell the difference between the coefficient and subscript. I have seen many children doing that. Whenever they are going to balance, they will simply put numbers here. They don't know the difference, what is going there, whether any difference is there between the coefficient or subscript. I think now you are clear. We are not going to change the subscript value because it gives a clear idea about a compound. If we change the subscript value, the compound is going to change. If the compound is changed, then that reaction is completely different. So, in a balancing, we are supposed to give values only to the coefficient. We can change the values in the coefficient side.
Now, we will go with the rules for balancing a chemical equation. What are the different steps we should follow when we balance a chemical equation? The first step, write down the given equation. There will be an equation for a reaction. So first step is to write the equation without any mistake. If any mistake is there, our balancing is going to be, it will not be a correct one. So first write the given equation properly. Then second one, down that you can make a column and write down the atoms present in the equation. What all atoms are present in the equation, you have to write it like one by one in a column. Third step, write down the number of atoms per element. How many atoms are present, that you can write that number close to that atoms. The fourth, start with a single element. First, we have to start with a single element, not with a compound or not with a molecule. Just find out a single atom and start with that. To balance, coefficients are added in front of the chemical formula until we have the same atom. First, we have to add, or we have to give numbers, we have to give coefficients. We are not supposed to change the subscript. We have to give the coefficients until we have the same atom, that is same amount of atoms on the both side, that is on the reactant side and the product side. Then balance the always save hydrogen and oxygen atom for last to balance. So after that balancing all the single elements, then we have to balance the hydrogen atom. Then only we have to balance the oxygen atom. And very important thing that we have to note is that never change the subscript of an element. Clear? So we have to follow these guidelines when we are writing and balancing an equation. Write down the given equation, write down the atoms present in the equation, write down the number of atoms per element, start with a single element. To balance, coefficients are added in front of the chemical formula until we have the same atom amount on both sides of the equation. Balance the hydrogen atoms, balance the oxygen atoms. Never change the subscript of an element. Clear for you? This can be easily explained, or we can understand by doing some simple examples.
So you are clear with the rules which we are going to follow to balance the equation. There are many different ways in which we can balance a chemical equation. But the rule which I gave, it feels little more simple for me. And I think it will be easy for you also to follow this rule. So we can go with the first example. So we are going to do a simple example, that is H2 plus O2 gives H2O. So since I am balancing, we are starting this, we are going through many steps. By learning this, it will be easy. After that, you don't need to write all these steps to balance the chemical equation. Only to understand the basic thing, we are going by step. Okay, first we will make a simple column like this. We will write here reactants. Which are the reactants? The starting material, that is hydrogen and oxygen, and the products. And we will write the elements here. Okay? Which are the elements? hydrogen and oxygen are present. Which are the reactants? How many number of reactants means we are writing here the number of reactants. How many hydrogen are there? 2. The subscript you can see 2 hydrogen atom in the reactant side. How many oxygen atoms are there? There are 2 oxygen atoms. In the product side you can see how many hydrogen atoms are there? It is 2. How many oxygen atoms are there? 1. Because it is no number, it means there is 1 oxygen atom. Then what is this balancing? Making the number of atoms on the reactant side and the product side equal. We are going to balance the number of atoms in the reactant side should be equal with the product side. So in the reactant side we can say that 2 hydrogen is there. In the product side also we can see 2 hydrogen. But in the case of oxygen we can see only 2 hydrogen atoms, oxygen atoms in the reactant side, but only 1 oxygen atom in the product side. So what we have to do? We have to balance the oxygen atom. To balance the oxygen 1 into 2, we can simply multiply this reactant with 2. We cannot write it here, so we have to write it here. If we write a number here, that means that number is common for both the hydrogen and the oxygen. If I am writing a number 2 here, that means it is for the whole water molecule. That means if I multiply here 2, I have to multiply here also 2. So now the oxygen number is 2 and the hydrogen number is changed into 4. You can see here it is 2 and 4. So again the problem comes what? Now the hydrogen is balanced, oxygen is balanced, 2 in the reactant and 2 in the product. What happened to the reactant side? Hydrogen is 2 and here the hydrogen is 4. We can see here hydrogen is alone and the oxygen is alone. So I can simply put a number here. It will be only for this hydrogen. So I just simply give a multiplication of 2 here. Now what is the number? 4. That is 4 here, 4 here, 2 here, 2 here. Clear? So now I can balance the equation very easily, like I can put the coefficients because already I got ideas from this step-by-step procedure. So what I will do, I will put here 2. We have multiplied it with 2, so 2H2O. Then I have multiplied a 2 here. So now you check 2H2. That means whenever we are giving a coefficient here and this coefficient is and this subscript we are multiplying. So 2 into 2. 2 into 2, that is 4, and here 2 into 2, it is 4. Here 2 oxygen, here also 2 oxygen. Clear? You got it? Now I'm not going to write these steps to balance this. Simply I will show how we can balance the equation by looking at the equation. H2 plus O2 gives H2O. When you are writing in a paper, better you balance by using a pencil. It will be easy for you to rub. So H2 plus O2 gives H2O. How many oxygen are there? 2 oxygen, 1 oxygen. So what I have to do? To convert into 2, I can never put here subscript, so I will put here 2. At the time oxygen is balanced. But what's the problem? Hydrogen is changed into 4. So I have to change this 2 into 4, means we know when 2 is multiplied with 2 we will get 4. 2H2 plus O2 gives 2H2O. Clear? We will go with the next example. A very simple example. Cu plus O2 gives CuO. Copper when reacted with oxygen, it produces copper oxide. This is also a very simple. First we will do the simple, then we will go with little more complicated. So what we have to write? We have to write the elements here, then the reactants, and then comes the product. When you are listening to the class, please keep a book and pen along with you, then you can do with me. Which are the elements? Copper is there, oxygen is there. How many copper are there in the reactant side? 1. How many are there in the oxygen atoms are there in the reactant side? 2. How many copper atoms are there? 1. And how many oxygen atoms are there in the product side? 1. Now you know that oxygen, there are 2 atoms, so I will multiply here 2. You look at the product. I cannot do it here, so I have to multiply here. That means I have to multiply with both the atoms. That means 2 Cu and 2 oxygen. So again the oxygen is balanced, but the problem comes at the copper. But it is not at all a problem. Copper is staying alone like that. So I can simply multiply the copper. I can give a coefficient there. That means 2 Cu plus O2 gives 2 CuO. You can check how many copper atoms are there? 2 copper atoms. How many oxygen atoms are there? 2 oxygen atom and 2 oxygen atom. This 2 is common for both copper and oxygen. That is copper oxide. So our equation is balanced. Clear? Now we can balance it without using these boxes. We can simply write like Cu plus O2 gives CuO. First I will look the equation. Copper is 1, copper is 1. So nothing I have to do there. Then oxygen 2, oxygen 1. So to make 1 into 2, I have to multiply 1 with 2. So now oxygen is 2, oxygen is 2. But the copper is here 2. Here it is 1. So I can easily make 1 into 2 by multiplying 1 with 2. Clear? The third example. Sodium chloride gives Na plus Cl2. Sodium plus chlorine is produced. Now again one more we are going to do with this columns. After that no more columns, we will directly do. That is reactants, the products, then the elements. Which are the elements? Sodium and chlorine. The reactant side, how many sodium are there? 1. How many chlorine? 1. How many sodium in the product side? 1. And how many chlorine in the product side? 2. Simple equation. Sodium is there 1. What we have to do with the chlorine? I have to make this 2 just by multiplying here 2. Again the thing is that sodium chloride is a compound. If I put here 2, then it is common for sodium also. So I have to multiply here also. So it is sodium is 2 and the chlorine is 2. The chlorine is balanced. What happens to the sodium? Sodium in the reactant side it is 2 and the product side is 1. So I have to multiply it with 2. So what happened? We have to give here 2 and we have to give here 2. Now we'll check the equation. 2 NaCl, that is 2 sodium, 2 sodium. 2 chlorine, 2 chlorine. So the equation is balanced. Example. Aluminium plus hydrochloric acid gives aluminium chloride and hydrogen gas is liberated. Again we are writing this column after learning. We don't want to write this column just to understand. I'm just writing this column. Elements, the number of atoms in the reactant side and the number of elements in the product side. So which are the elements? Aluminium, hydrogen and chlorine. How many elements, aluminium elements are there on the reactant side? 1. How many hydrogen? 1. How many chlorine? 1. How many aluminium are there in the product side? 1. How many hydrogen? 2. The chlorine? Hydrogen it is 2 and chlorine it is 3. Now we have learned in that steps, that is balancing. First we have to balance the elements, then only we will go with the hydrogen and oxygen. Here aluminium is already balanced. Then comes the chlorine. Here we can see in the product side it is 3 and in the reactant side it is 1. So we will multiply this with 3 And we will check where this chlorine is. Chlorine in the reactant side is produced. That is, in the reactant side is at the HCl. It is the part of the HCl. So whatever I am multiplying, I should multiply with the hydrogen also. Since I multiplied with 3, so I have to multiply the hydrogen also with 3. Now I balanced this chlorine 3, hydrogen 3, and the hydrogen at the product side is 2. Again, what is the problem? Hydrogen it is 3 and here the hydrogen is 2. This is an odd number and this is an even number. How I can make them balanced? The only number we will check. If I multiply it with 3, ones are 3. No change. If I multiply it with 2, I will get 6. Okay. So I have to multiply this also with a number which makes them 6. That is, when I multiply the 2 with 3, I will get 6. Check it. In order to balance hydrogen, we got hydrogen as 3. So here the hydrogen was 2. What was the number of hydrogen on the product side was 2 and the reactant side was 3. When it was an even number, it was so easy. Like just we know the multiplication table of that number, we can easily write. But since both the numbers are different, we have to find a common number, which is the least common number, which can make them a simple whole number. That is, if I multiply 3 with 2, I can get a number 6. The same thing I have to do it here also. To make the same number, I cannot multiply with 2. If I multiply with 2, the number will be 4. So I can multiply it with 3. So it will be changed into 6. What I multiply in the reactant side, I am multiplying it with 2. And in the product side also, I am multiplying it with 3. The reactant side, we can see that the hydrogen is along with the chlorine. So I have to multiply this also with 2. Then I will change this chlorine into 6. Here, if I multiply hydrogen with 3, no other element I have to change. But again, the problem comes what? The chlorine here it is 3 and here the chlorine is 6. What I have to do? I have to change this into 6 by multiplying it with 2. What happened? Now it is changed into 6. But this chlorine is along with aluminium. The chlorine is along with aluminium. So what I have to do? I have to multiply it with 2. So it changes into 2 aluminium. But what is the reactant side? Reactant side only 1 aluminium was there. So I will again multiply it with 2. Now we will check the equation. 2 aluminium, 2 aluminium. 6 hydrogen, 6 hydrogen. 6 chlorine, 6 chlorine. So what I have to do? I have to write here 2. Then I have to write here 3 into 2, it is 6. So I have to write it 6. Already we multiplied first with 3, then with 2. That means 3 into 2, I have to write it is 6. In here aluminium, we will check it is multiplied with 2 only. So I will write here 2. And in the hydrogen side, we have multiplied it with 3. So we will write here 3. Now we will check our equation. 2 aluminium, 2 aluminium. 6Cl, 3 2s are 6Cl, 6 hydrogen, 6 hydrogen. I know this is little bit, you will see it like what all things we have written. Since I have written it like this, will be little bit confusing. Once more I will explain. I'm explaining those who didn't get an idea just once more, okay? It will be easy. Which are the elements? Aluminium, hydrogen, chlorine. The number of elements on the reactant side 1, 1, 1. Product side 1 aluminium, 2 hydrogen and 3 chlorine. Clear? Now we will go with it. How many aluminiums are there in the reactant side? 1 aluminium, 1 hydrogen, 1 chlorine and 1 aluminium, 2 hydrogen and 3 chlorine atom. What we have learned in our rules? Before balancing hydrogen or oxygen, first we will have to balance the elements which are other than hydrogen and oxygen. Here aluminum is there, chlorine is there. Aluminum, we can check one aluminum, one aluminum. So we don't want to balance aluminum. Next comes the chlorine. How many chlorine are there in the product side? It is 3. How many chlorine are there in the reactant side? 1. So what I have to do? I have to multiply it with 3. I am just giving an underline because in order to understand what all numbers we are multiplying. So we are multiplying 3. So we will balance this as 3. But before completing, you have to check where this chlorine is there in the reactant side. It is there with the hydrogen chloride. So whatever number we are giving here, we have to multiply it with hydrogen also. So I will multiply this 3 with the hydrogen. So we will get the product as 3 hydrogen and 3 chlorine. Here the chlorine is balanced, but what happened? This hydrogen is again get changed. That is 3 hydrogen here and 2 hydrogen here. So what I have to do? I have to balance this. Not by simply multiplying with a common number. We have to multiply it with a common number which can change. We cannot multiply it with a common number because this is an odd number and this is an even number. So we have to find out a number which gives an equal number for when it is multiplied with this number. We should get a number which is common for both. If I multiply with 1, no change will be there. 3 into 2. So I am multiplying it with 2. So I will get 6. Now the hydrogen atom is 6. To balance this also, I can multiply it with 3. It will be 6. But we will check here first. Since I have multiplied hydrogen with 2, the hydrogen is present with chlorine. So I have to multiply this chlorine also again with 2. So it will be changed into 6. So I have multiplied this chlorine and hydrogen with 2 numbers. That is 3 and 2. Here also 3 and 2. Here I multiplied hydrogen with 3. Hydrogen is alone. So no problem. We don't want to multiply any other number. But the problem again comes. Now the chlorine is 6. But here the product side chlorine is 3. So what I have to do? I have to make it 6 by multiplying it with 2. Now I get 6. But chlorine is not alone. It is present with aluminium. So aluminium should also be multiplied. So I will get 2 aluminium. So what I have to do? I have to balance here. So I have to put here 2. So I get 2. Now we will check. 2 aluminium, 2 aluminium. 6 hydrogen atom, 6 hydrogen atom. 6 chlorine atom, 6 chlorine atom. You got it? Now we have to give the coefficients. I have given this multiplication like this. So you can see 2 aluminium. Okay. I have multiplied hydrogen with 2 numbers 3 and 2. 3 2s are 6. So I have to give 6. The same here also, chlorine also. Whatever I have multiplied in hydrogen, the same thing will be happening in chlorine. So 6 sets here. In the product side, I have given 2 for both aluminium and for chlorine. So I have put here 2. And here hydrogen we have given 3. Now we will check our equation. 2Al, 2Al. 6 hydrogen, 3 into 2. 6 hydrogen, 6 chlorine, 3 into 2. 6 chlorine. Now the equation is balanced. Clear? You can clear? You can check this once more. Just go through that. Whenever you are writing this equation, keep a paper and pen in front of you. Then it will be easy for you to do along with me. And if you have any confusion, you can pause it and again you can check. Okay. So KNO3 plus H2CO3 gives K2CO3 plus HNO3. Here we get found that elements potassium, nitrogen, oxygen and hydrogen. How many potassium are there in the reactant side? 1. How many nitrogen are there? 1. Then how many oxygen? Here also in the 2 reactants we can see oxygen. So here 3 and here 3. When the elements are present in this reactant side with the 2 compounds, we have to add that number. So how many oxygen are there? 3. plus 3. So altogether it is 6. In the case of hydrogen, in the reactant side, we can see only 2 hydrogen atoms. How many hydrogen atoms are there? There are 2 hydrogen atoms. Now we will go with the product side. How many potassium atoms are there? 2. How many carbon atoms? One more element was there, carbon. How many carbon atoms are there? 1 reactant side and 1 in the product side. 1 in the product side. So 1 in the product side. We can see how many nitrogen atom? 1 nitrogen atom. How many oxygen atom? Altogether 6. 3 plus 3. Then how many hydrogen atom? 1 hydrogen atom. Here we can see many numbers with different number. Like here already we learned in that before balancing we have to balance the elements. Then only we will go with the hydrogen and oxygen. So first we will go with the elements like potassium, nitrogen and carbon. Here we can see carbon is 1, 1, nitrogen is 1, 1. First element is potassium. In the reactant side it is 1 and the product side it is 2. So what we will do, we will listen carefully because lot of numbers are there. So properly you have to listen. We will multiply it with 2. So we will get potassium 2. Potassium is not alone, it is along with the compound like potassium and nitrogen. So I have to multiply it with 2 to produce 2. Then this 2 is common for oxygen also. So 3 into 2. So I have to multiply here also 2. Then it will become 12. Clear? Now next comes, we will check with the numbers. Nitrogen is changed to 2. So what I have to do? I have to multiply the nitrogen with 2 to make it balanced. If I multiply 2 here, the nitrogen is balanced, but again hydrogen and oxygen is there. So I have to multiply it again with 2 to produce, it will get 2. And one oxygen is there, so I will have to multiply it also with 2. That is 12. You got it? So we will take carbon 1, hydrogen 2, oxygen 12, nitrogen 2, potassium 2. Simple. So now we will give the coefficient. We have given 2 for potassium nitrate. Then here 2 for HNO3. 2. Now we will check our equation. 2 potassium, 2 potassium. 2 nitrogen, 2 nitrogen. 6 plus 3, 9 oxygen. 3 to 6 plus 3, 3 into 2, 6 plus 3, 6 plus 3, it is equal to 9 oxygen. So it is balanced. Then hydrogen 2, 2 hydrogen, carbon 1, carbon 1. So our equation is balanced. Check this one more, then you get be easy. Clear? Next example. From this example onwards, we are not going to write the columns. We will directly go with the balancing from the equation itself. Better you use a pencil because we have to rub. So better you use a pencil to write the balancing first. So, how many sodium are there? 1 sodium, 1 sodium. How many bromine atoms are there? 2 bromine. Here 1 bromine and here it is 2 bromine. So I'll just simply give here 2. So first you will check 2 bromine is there, but the problem is that 2 Na. So I have to balance this Na by giving here 2. So it is 2 Na, 2 Na. And this Cl is 2 and this Cl is 2. So the equation is balanced. Clear? That is 2 NaBr plus Cl2 gives NaCl plus Br2. This was a very simple one. Next one, Al plus H2O gives Al2O3 plus H2. Al plus H2O gives Al2O3 plus H2. Simple equation. We will check. How many Al? 2 Al. Then 2 Al, 2 Al. How many oxygen there are? 3 oxygen. 2 hydrogen is there, 3 oxygen. So I will just give it here 3. So 3 oxygen, but the number of hydrogen is changed into 6. So to make this 6, I can multiply here with 3. So what happened? Now everything is balanced. 2 Al, 6 hydrogen and 3 oxygen. It is balanced. The next one. Magnesium plus water gives magnesium hydroxide plus hydrogen gas. Here we are seeing a simple like this. A bracket comes here and a 2 outside here. It's nothing. This is a hydroxide and it is just given a number 2 here, means this 2 is common for both oxygen and for both hydrogen. This bracket represents that this 2 is common for both hydrogen and oxygen. So what we are going to do, we have to balance. Magnesium 1, magnesium 1. 1 oxygen, 2 oxygen. 2 hydrogen, 2 plus 2, 4 hydrogen. So I have to balance this 2 oxygen. First we will balance with the 2 hydrogen. So whatever we are doing, we have to put here 2. So what happened? 2 hydrogen. It's 4 hydrogen. 2 plus 2, 4. 2 oxygen. 2 oxygen. Very simple. Barium hydroxide plus HCl gives barium chloride plus water. Which are the elements on the reactant side? Barium is there, oxygen is there, hydrogen is there, chlorine is there. So first we will go with barium 1, no problem. There are 2 chlorine, there are 1 chlorine. So to balance it, I will put here 2. So 2 chlorine, 2 chlorine. 2 hydrogen, but it's 2 plus 2 hydrogen, it is 4. So to balance it here, I am giving it 2. Now we'll take 1 barium, 2 chlorine, 2 chlorine, 2 hydrogen, 2 plus 2, 4 hydrogen, 4 hydrogen, 2 oxygen, 2 oxygen. Clear? So the last example which I will do for you, either you will go with the example worksheets and try every example, then finally you have to check the answer, then only you will learn. So PCl5 plus H2O gives H3PO4 plus HCl. So here phosphorus is there, chlorine is there, hydrogen is there, oxygen is there. First we will check with 1 phosphorus, so no problem. 5 chlorine, 1 chlorine. To balance it, I will put here 5. So 5 chlorine, then 5, here oxygen it is 4. So first we will balance with the hydrogen. 5 hydrogen, 5 plus 3, that is 8. 8 hydrogen and here it is only 2 hydrogen. So how can make it 2 into 8, that is multiplying it with 4. 4 2s are 8 and it is 4 oxygen. Here also 4 oxygen. Phosphorus, 1 phosphorus. 5 chlorine, 5 chlorine. 8 hydrogen, it is 3 plus 5, 8 hydrogen. 4 oxygen, 4 oxygen. So the equation is balanced. So next what we will do, I will give you some some questions you can do with your own. And finally I will give the answer also. You will check with that answers. So I think it will be clear now. Balancing is very easy for you. Is it? It's clear for you? If you have any doubts, you can write in the comment section, or you can, if you're not getting any problem, you want to explain it more, just write in the comment section. We will do it for you. Clear with us? Thank you.